Hello, I'm Tony Dubio and I'm a technical solutions architect working for Cisco Cloud and Managed Services Organization. Today I'd like to give you a brief overview of our Intercloud Fabric Business Edition, which is a tool set that allows for hybrid connectivity and internetworking between a customer's private cloud and a public cloud provider. This video should take approximately 30 minutes to complete. Primarily, we'll focus on use cases to help a customer envision how they might be able to leverage Cisco Intercloud Fabric Business Edition to connect to public cloud providers and to provide access to services, as well as the ability to interoperate and to stitch together enterprise data center services to make them available to workloads that would run in the public cloud provider. As we move forward in additional videos as a part of this series, I will also try to provide various demos with a specific focus on a particular use case in order to make them modular and to point out various use cases that would provide services for more traditional applications and workloads, as opposed to newer cloud native applications and workloads that would leverage this tool set differently, and in some cases are needing some features and functionality that's a part of our roadmap that may or may not be available. So I'll point out some of the futures versus the existing capabilities that align with each specific demo. At this point, I'd like to give you a quick baseline overview of the product. As you can see here, the product is represented as a software suite. The Intercloud Fabric for Business is installed currently in a VMware environment as OVA files, and then we have subsequent templates that we use to support Red Hat KVM, OpenStack, Hyper-V. It can be delivered in multiple ways, but essentially this is software. And as we proceed into various videos and demos, I'll point out the components of this software in more detail. But at a high level, it's meant to be hardware agnostic, in that the software stack essentially is delivered as software on top of any server hardware. And then the intention, again, is to be hypervisor agnostic, in that we support multiple hypervisor vendors and open source options from OpenStack. One of the things to point out is that we deliver the capabilities and expose them within a single console. So this provides an IT admin portal to provision resources in order to either migrate workloads to a provider cloud, or to spin up and spawn new instantiations based off of templates that we upload into the tool set that we can make available in multiple providers. And then obviously we're able to stitch these clouds together through our networking features and security. Another availability in terms of connecting to and provisioning this system is to take advantage of the northbound API. So currently it's a subset of capabilities that primarily focus on virtual machine lifecycle management in terms of powering on a virtual machine instance, or powering it off, or migrating it to a cloud provider, or migrating it back to the private cloud from a public cloud provider, as well as instantiating instances based off of images that have been pre-uploaded into the system. We can accomplish those functions by leveraging a northbound API. Why is that important? If you have your own software, if you have the ability to make an API call from your software, or perhaps you've purchased a cloud management software suite that has the ability to leverage APIs, then you can configure the Intercloud Fabric Business Edition that way, as well as scripting. We have a RESTful API browser, so you can make API calls directly to the system from scripts. You can use Python or curl scripts, etc. to make these API calls. What I'd like to do is table that discussion in this video, and then to spend some time drilling down into some of those API options later in a separate video where we can leverage scripting to make an API call to migrate a virtual machine. And again, the intention here is to provide a secure platform that's hypervisor agnostic, as well as agnostic from a provider standpoint as well. So if you look over here, we have a robust ecosystem of providers that are a part of the Cisco powered Intercloud Partner Program. And then we have some of the over-the-top, hyperscale types of cloud providers such as AWS and Azure that, again, we facilitate connectivity to these providers and then provide a network and security platform that allows them to interoperate together. So a lot of that functionality is based on Cisco products that are delivered as virtual appliances. And the value here is that the Intercloud Fabric Business Edition orchestrates and automates the provisioning of these virtual appliances. So it's delivered as a system that makes it very easy to connect to a cloud provider, but to also extend the customer's infrastructure and their private IP into these environments. And I'd like to spend more time unpacking that later. And again, some of this will be in subsequent videos. So today, the focus is squarely on use cases and reasons why we would use this tool set. And on the next video, I will attempt to deep dive into how this product functions and the components and complexity under the hood, but how we deliver it and make it very easy for the customer to use these extensive features and capabilities either through an API or through our user interface and GUI IT administrative console. If we take a look at the first use case, interoperability, this provides us the platform to facilitate onboarding, securely onboarding virtual machines into a provider cloud, which provides portability. But there's also a lot of value and reasons why we need internetworking between these clouds. Many of the hybrid solutions available today focus more on API integration with the provider cloud to orchestrate the ability to migrate or instantiate virtual machines in the provider cloud. But what they fail to do is to orchestrate and provide that secure fabric, that overlay of connectivity to connect the clouds together and to allow for networking interoperability. So in our solution, again, we are extending the customer's private cloud into a public cloud provider. There's a lot of value there because up until this point in time, predating this type of solution, a customer more than likely would need to consume dedicated resources in terms of either a colo, and in a colo, the customer has more responsibility around their infrastructure as a service in terms of compute, networking, and storage. Taking that a step further, many providers offer in an OpEx model dedicated compute, network, and storage, but it's sold at a premium. What this solution allows for is to extend the customer's private cloud into public cloud as if it were a private cloud as a service, but leveraging public cloud resources at a lower price point. Meaning, when you connect to an Azure or an AWS environment, those are shared hypervisors. Those instances of virtual machines are sold at a very low cost point because it is made available in a multi-tenant environment. What we're doing is adding a secure wrapper around that and then using our network technology and security to leverage a encrypted connection between the two clouds. This is not a typical site-to-site VPN. In AWS, that's a VPC service. or a direct connect where the customer is consuming private MPLS service to cross-connect their data center into AWS, but it doesn't integrate in with their IP addressing, which means the customer has to configure routing and NATing and access control list on both sides in order to provide connectivity across a single subnet. In our approach, we are actually extending layer 2 into the provider cloud based off of the customer's network. So in those layer 2 LAN extensions, we leverage 802.1q trunking to actually extend multiple VLANs through a tunnel. And then by introducing routing functionality in the provider cloud, we give our customer an option to route between VLANs and to localize that routing so there's no need to backhaul traffic across that tunnel. That secure fabric, which is encapsulated as an SSL VPN, can operate over the internet or can function on any private layer 3 network. So if the customer has MPLS service, a direct connect service, in terms of connecting to AWS or express route to Azure or any other type of private link type of connectivity to a cloud provider, this overlay, the secure fabric, can operate over those environments, as well as really any MPLS, VPLS, any private networking layer 3 configuration would work. So that's how we connect to the provider cloud in terms of networking. Now, the types of applications that benefit from this connectivity are twofold. There's traditional applications that are typically 3-tiered and transactional. And because they're transactional, that means that normally they're built in a scale-up model. So whether that is in bare metal in terms of installing an operating system on top of a compute environment, a blade, if you will, or if they're packaged into a virtual machine, oftentimes several application processes and perhaps some middleware and maybe even the database are packaged into a single virtual machine. And even when they're separated in terms of creating tiers between the web front end, the presentation tier, the application servers and processes, and then the back end database, there is a dependency on the availability of the underlying infrastructure, the compute, the network, and the storage. And the dependency means that oftentimes the front end, the presentation tier, is pointing to a specific IP address for a specific transaction that is stateful to a particular application server. So if you have a problem with that compute environment, that specific application server or the network that connects the tiers between each other, then perhaps a transaction would then fail. So a lot of dependencies on the infrastructure, hence the requirement to introduce redundancy from an infrastructure perspective. Now, when customers start to migrate those types of traditional application stacks into a provider cloud, if they're moving into a dedicated private cloud, a hosted private cloud that exists externally in a provider cloud, then if they're able to lift and shift the entire environment, then that reduces some of the risk. In dedicated private cloud, the customer has more of control of the services and the types of virtual machines and the types of bare metal machines that they can onboard into an infrastructure as a service that's hosted remotely in a private infrastructure as a service. In the case of public cloud, it can become very difficult to lift and shift, because now whether it be a virtual machine or a subscription to an as-a-service option, such as a load balancer or a database, etc., then those options may or may not work for a particular traditional 3-tiered application. So when we start to look at dependencies, then that could cause the need to reevaluate migrating and onboarding into a provider cloud. Some examples such as file systems. An application server may need to connect to a particular file server that exists in the enterprise data center. It could be very difficult and challenging to replicate that file server and those files into a duplicate file server that's represented as a virtual machine in the provider cloud. And then note that anything as it exists in the provider cloud incurs charges in the case of public cloud being more of a metered service. So it may not be cost, the cost impact may be prohibitive to run some of these types of services in the provider cloud. There's examples such as DNS. I mentioned in stateful, there's dependencies on IP addressing. Oftentimes name search space, the host names of the servers is important, and in a transactional application, it may point to a specific DNS name. So replicating DNS or subscribing to DNS services such as Route 53 in AWS may be cost prohibitive as well. Identity management integration into LDAP may or may not work depending on the provider and what they support, such as nested OUs and things of that nature that could become very complex in an Active Directory environment. May or may not be able to work in a structure that may need to be flat, as an example. So those types of things need to be taken into consideration, and with Intercloud Fabric, we can provide a workaround. So if there's any particular service that needs to reside as it exists in the enterprise data center, we can certainly provide a connection and extend that network, and to be able to route between those VLANs that we've extended locally, as well as allowing them to route back to the enterprise data center. We can provide reachability and access to particular services. So in the example, you may move the entire application stack to the provider cloud, but leverage particular services and dependencies in the enterprise data center, or perhaps the customer opts to only migrate a subset of the application stack to the provider cloud, such as the web front end or application servers, and perhaps the database remains on premise. Or perhaps it's the opposite scenario where the customer opts to subscribe to a database as a service from the provider cloud, but leverages the internetworking and interoperability to connect remotely to that database as a service from application servers that reside on premise. Another aspect of this is capacity augmentation that I'll show you in more detail in a use case slide. But essentially how that would work is introducing load balancers, either as virtual machines that are imported into the provider cloud environment as part of the Intercloud Fabric tenant environment that we instantiate and create as an overlay on top of the provider infrastructure as a service. Or perhaps the customer is subscribing to a load balancer as a service. An example would be AWS Elastic Load Balancing, where it's provided as a service, and those public IPs would be fronted by VIPs that exist in Amazon's load balancing service. That's a way of introducing elasticity into a traditional application stack that would allow for options for auto scaling, right? So as you introduce load balancers, you can spawn copies of application servers or web servers that would allow you to benefit from horizontally scaling out in the provider cloud. So that's a very interesting use case. Moving forward beyond traditional onboarding, which normally alludes to a production workload that resides in the cloud, there's other use cases and other aspects of the lines of business and application owners and developers who also focus on dev test if the customer has their own software. In traditional terms, in traditional applications, normally dev test has a strict demarcation point between a developer environment, a sandbox environment, if you will, where code is developed and tested, versus the production data center and environment that normally the developers have no access to. So there's a process that's in place that's a part of the software development lifecycle process where code is designed, agreed upon, updated, tested with processes in place to involve the operations teams and again a handoff between those teams. Now, what you'll find is that development sandbox, and depending on the type of application, updates to that software may not occur frequently enough to justify being able to reserve certain capacity in terms of hardware, compute, network and storage to make those environments available all the time. So what some developers find themselves in is a situation where they're procuring available capacity to build a sandbox. And in some cases, when there's not existing capacity, it could take a bit of a turnaround time for operations teams to build out new infrastructure for dev teams. And that's an area where we're starting to see developers leveraging the public cloud for two reasons. One reason is simply for capacity, to have somewhere to easily spin up virtual machines, in the public cloud. Or the developers may access the public cloud to have access to tool sets that are not available in their current private cloud. So depending on the type of hypervisor and orchestration available in their private cloud, it may prevent them from leveraging some of the newer, more agile types of tool sets that you can simply subscribe to from a DevOps perspective in public cloud providers. In DevOps, it's a little bit different, slightly different than dev test in that instead of a manual process and a handoff to the operations teams, oftentimes the complete process of testing and delivering code and promoting workloads into production is a function of a DevOps software, a platform as a service offering from a provider. In either case, if the customer is connecting to the public cloud provider, we can secure through an encrypted tunnel with AES encryption the private cloud to the public cloud to allow for the developer to either access capacity or tool sets or both, and to develop, update code, and then ultimately bring those virtual machine workloads back to the production data center where they can be handed off for additional testing, and rigor from the operations teams to promote those workloads into production. In many cases, it's fine to build a test bed in a public cloud provider, but because of other compliance reasons, performance, SLAs, etc., it makes more sense for those workloads to ultimately be deployed in production within the customer's own data center. Capacity augmentation offers the customer flexibility in being able to use a provider cloud as needed, sort of an insurance policy, if you will. If for some reason, there's an unforeseen event, which typically are hard to prepare for because we consume hardware resources in our private cloud and build out as much capacity as we think we need to service burst in load to particular applications. But what about those unforeseen events or those viral types events where capacity is bursted, load is explodes way past what we prepared for, and options to build additional servers on demand typically is not fast enough. So how do we deliver and make capacity available in a rapid manner? This is an area where Intercloud Fabric can provide an option to connect, again, securely to the provider cloud and to inter-network the environment, so to maintain the customer's private IPs, and to allow for instantiating copies of either the web front end or perhaps application servers in the provider cloud. Again, other functions of network, load balancing, policies to introduce auto scaling would be required, in addition to capacity, but with taking those into consideration and either leveraging the provider's service, their elasticity service in load balancing services, or importing templates of virtual appliances, such as load balancers, to be able to front the IP, and then to be able to ultimately scale out and to horizontally provide additional capacity through copies of spawning additional virtual machines that represent the application in the provider cloud, would allow for ultimately unlimited capacity in terms of once you connect to the provider cloud, you have all of the hardware resources at your disposal to instantiate additional copies of those applications. When the event subsides and the load would ultimately would fall beneath a threshold, then you can certainly decommission those virtual machines, turn them off, and and then would stop incurring usage fees. So pay as you use. To complete this first session based on Intercloud Fabric Business Edition use cases, I would like to end with the multi-cloud use case, which is a very interesting capability of Intercloud Fabric Business Edition, being able to connect to not only a single provider, but to connect to multiple providers and to extend the same layer 2 LAN extension and customer private IP into multiple providers to allow for internetworking the tenant's environment between both of those external clouds and their private cloud. In this example, what we see and what you'll see in a subsequent video in more detail through my demo capability is the ability to internetwork between these providers. This represents an example of a 3-tiered application where we've taken and we've instantiated a web server with a public IP in Windows Azure, as well as an application server that resides in AWS, and a database that remains functioning on the customer's internal enterprise data center and private cloud, with internetworking the environment together using the Intercloud Fabric Business Edition Secure Fabric, encrypted SSL tunnels between the two environments, where we've extended the layer 2 environment, the VLAN and IP subnet that is routable between these devices and these 3 tiers to ultimately allow for a 3-tiered application to benefit from capabilities of the provider cloud, as well as reachability and access to services and data that continues to function in the enterprise data center. Additionally, in a demo, I will show an example of subscribing to a database service from Microsoft Azure that's routable within the customer's private IP addressing that's allocated as part of the infrastructure as a service that Azure provides to the end customer, and stitching that together by using the routing that's provided in Intercloud Fabric Business Edition to essentially make that SQL Server routable and accessible from Microsoft Azure. In this example, it resides in the enterprise data center, but we can certainly subscribe to database as a service or migrate a database as a virtual machine instance into a provider cloud, and through networking and security, make those resources and data available from virtual machines that reside in various other external clouds or on-premise data center and private cloud. I'd like to thank you for your time and attention during this video, and I look forward to your attendance on other videos that will drill down into more details on how Intercloud Fabric Business Edition works under the hood, as well as specific demonstrations as proof points to show these use cases in action using a live demo of Intercloud Fabric Business Edition. Thank you, and have a great day.